All right, this last section here is still for solving equations in one variable, but this time we're going to be talking about no solutions and infinitely many solutions within these equations. So my I can statement here is solve equations and know if they have one solution, no solutions, or many solutions. So we actually have great news. We're going to do everything the exact same that we have been doing to solve these equations. And so the difference is then that we just have to decide if the result gives us a true or a false statement. So we're going to look at some examples here, and then we'll talk about kind of the recap, and then we will be done. So here is an example of an equation that is going to have no solutions. And so I just want to walk through this so that we can recognize that we're going to solve exactly the same, and then at the end we will have this result that is going to be either true or false. So 5x plus 12, that part isn't going to change, but I do notice over on the other side that I have some like terms that I would like to take care of first. So that's going to leave me with 5x plus 8. So now I want to group my x terms together on the same side of the equation, so I want them over here on the left. And right at this point, I notice something interesting is going to happen. I've got 5x minus 5x over here, and those are going to cancel, and that's what I wanted to have happen. It leaves me with 8. But then over here, I also notice that 5x minus 5x is going to cancel on this side as well. And so what has happened is there are no terms that have x left in my equation. And so all I'm left with here is this equation that says 12 equals 8. And remember that I'm looking at what is equals mean. Are these things the same? Are they going to result in a true or a false statement? Well, for as long as I've been doing this, 12 does not equal 8. This is false. And so because it's false and x cancels on both sides, there are no x values that will ever allow me to have these two statements be equal. So there is no solution because I resulted in a false statement. And again, what no solution means is there are no x values possible for me to plug in to here to check my answer that would ever allow for these two pieces to be equal. Okay, so no solution is when I get a false statement. Infinitely many solutions is going to look just a little bit different. Okay, it doesn't change how we solve. We're still going to solve the exact same way. So in this problem, I still need to do the distributive property first. So I've got 6 times x, which is 6x, and then 6 times negative 1 is minus 6 equals 6x minus 6. So again, I'm going to solve like normal. I'm going to move my 6x over here so that I have my x terms grouped together. And they're going to cancel, and I'm going to be left with negative 6 over here on this side of my equal sign. Over here, I'm going to have negative 6. 6 minus 6 is also going to cancel again. And what's left is this negative 6. And so now when I look at this equation, I have negative 6 equals negative 6. Again, all of my x terms have canceled. I have no more variables left. But in terms of something being equal, yeah, negative 6 is always going to be equal to negative 6. That is a true statement. And because it doesn't tell me what x is not negative 6 in this case. X is lots and lots of numbers. There are lots of numbers that I can plug in for x that will give me the same thing over here, because these two pieces are essentially the exact same. So this true statement tells me that I have infinitely many solutions. And if you don't believe me, try just a couple different values for x, plug them in, and you will end up with the same answer on both sides of your equal sign. So infinitely many solutions for this one. Notice that it was a true statement and that I have no variables left. I was not able to decide in this case what x equals because x cancels out of the problem altogether. So then the last scenario is when there's one solution, and this is what we have been doing for quite some time. And so I want to show you how this works and how it's different than the ones that we have been working on. So I'm going to start solving this just like normal. I want to bring this 2x over here so that my x's are grouped together. On this side of my equal sign, the x's cancel and I have negative 8 left. And over here I'm left with 2x plus 12. I then would take my numbers over here to the other side, away from my x term, and the 12s will cancel. I now have 2x equals negative 20. And then lastly, I can divide, and I'm left with x equals negative 10. Now I can take this negative 10 that it tells me that x is, and I can plug it into my equation and check it out. So I would have 4 times negative 10 plus 12. Does that equal, and I'm going to put a little question mark there, does that equal 2 times negative 10 minus 8? Well, let's check it out. Negative 40 plus 12, does that equal negative 20 minus 8? This is going to give me negative 28 equals negative 28. And so it does work out as a true statement that x does equal 10, and it makes this piece equal this piece. Okay, so this has one solution and one solution only. It only is true when x equals 10. That's the only time. So here's just a quick recap. If you solve your equation and you get down to a false statement, there are no solutions. It's the only time in which you get a false statement that you will have anything. So if you get false, it's no solution. If you get true, it could be one of two things. It could be infinitely many, or it could be one solution. And so we have to go on and see what's left. If there are no variables left and we get a true statement, then it tells me there are infinitely many solutions. But if we get that true statement and we still have a variable like an x or an m or a k or whatever our variable is, and it's still in our equation with a number, then we just have that one solution, just like we have been solving for this entire unit. So go ahead and take a look at your assignment. Let me know what questions you have.